Hello guys, my name is Suraj and welcome to Tactiles AI. We'll be working on this beautiful topic that is YOLO V8 image detection. This video will be a little bit long, so stick with it and you'll get to know a lot about how we can segment the images using this YOLO V8 algorithm. Stick with me and you'll get to know a lot of things about it.
Before proceeding into this YOLO V8 segmentation, the image segmentation, tell you a few things prior to that. What notebook we'll be using, what kind of get repo we'll be using, and what kind of model we'll be using. First, for the part of notebook, I'll be using Google Colab because it's quite handy and it will be available for all the people, and you really need not to worry about the dependencies and to create a virtual environment and all to set up all the things. Everything will be taken care by this Google Colab. You just need to import the libraries. That's it. So for that sake of thing, and I'll also let you know how you can, where you have to put your all the data. I'll be using the drive so that you can, easily whenever you have to open up your Google Colab, the PYLB file, you really need not to again set up all your libraries and directories. So for that sake of thing, I'll let you know how you're gonna do that, and we'll be using. I'll mount the drive. I'll show you each and every step. So be with me, and along that thing, I'll be using this Ultralytics, repo, and here I'll download the pre-trained model, and also I'll be using a model for the YOLO V8 segmentation part. So along the segmentation, YOLO V8 also perform detection classification. So this YOLO V8 is really helpful. While the name suggests it's you only look once, so it's really a single detection model, single shot detection model. So it's quite fast if we compare this model with TensorFlow Mask or CNN. It's actually very fast, but it's not that much accurate as TensorFlow Mask or CNN, because in TensorFlow Mask or CNN we have like a double shot detection model. So it's like a single shot detection model. So it's only used one time image to detect things out, but like in TensorFlow Mask or CNN, it's actually uh, you know figure out two times, so it's quite accurate to use the TensorFlow Mask RCN. In my next videos, I'm going to be uploaded the TensorFlow Mask RCN and the segmentation too, but this time we'll be using this YOLO V8 because it's quite fast and it will give you very good. It's not that much, not if you compare this TensorFlow with YOLO V8, YOLO V8 is quite good. It's not like that it's not giving you an accurate result. It's not like that. It will give you an accurate result, but if you compare your predictions with TensorFlow, Mask, RCNN, I would say it's TensorFlow, Mask, RCNN is one step ahead than Euro V8, but it's really new, so we need to perform the task. So I'll be using this YOLO V8 as segmentation because this YOLO V8 it has segmentation quite optimized as per my environment, because I'm using Colab. So because Colab have very limited GPU. So if you do have like a good amount of storage and GPU support, then you can use different stuff. But I'm using this YOLO V8s, so I'll suggest you to use this thing if you're using Google Colab with me, right? So like I'll upload all the notebooks. You really need not to worry about. You just need to change your data set and get your optimized and your your results. But if you're doing it with alongside with me, that is very fine. You'll learn all the things a lot. What I'll do is I'll download this YOLO V8. I already have downloaded. I'll let you know where I have downloaded. Here you can see YOLO V8 as. So if you haven't downloaded this thing, you can go over there. You can click it up, and it will automatically get downloaded. Right. So first of all, you need to download this things. Use this thing. Let you know where I have used this thing. So just download this file. Second thing which you need to do is you need to find some images to get segmented, right? So I have used this images of traffic. So like, same stuff, you can snip it up and you can just download all these things in your desktop. So like I have in my folder, in my YouTube video folder, I have downloaded just 15 images of traffic. So we have used this thing. So what I'm going to do is I'm going to segment out different objects in the road, like you can see car, scooty, and truck. So will be people. So will be segmented all these things. So I have used these 15 images. So first of all, what I'm going to do is now you have downloaded the images. The second step would be annotating them. So why we annotate these images? First of all, we need to understand this thing. So as we know, we have done some conventional machine learning models. So we have to label up our data. So you can understand this thing like that. It is actually label your data. So if you're using TensorFlow Mask RCNN, like it will convert those images and annotate it into JSON file. But here it will convert into some different stuff. We'll see in what format we have to, convert this thing. So let's stick with it and let's just perform all our annotation tasks. So we'll go to this thing. This is RoboFlow. I'll again show how you have to go through this thing. So you'll go there in this thing in RoboFlow. This is a tool which is used for annotation. Not necessary to use this tool, this RoboFlow. You can use any annotation tool. The things would be same. So where you will go to the create new project. You're doing this instance segmentation. You will this instance segmentation. What I'm detecting. So I'm detecting objects on road. So I'll list out this thing objects on road. So that right. So it just right objects. Okay. So the project name would be, let's say the project name is objects on road. This is my project name. So I create this public project. So now you can see over here. You can upload some images. So I'll upload my images here. So you can go to your directory and you can upload all the images like Colal and select. So it will pre-process some files and we can see there are like 15 files with us. So we'll go and save and continue this thing. So it will be uploading soon. Okay, so we can see file already got uploaded. So I'll assign the images. Now we'll perform our first task, that is annotation. You can see there are 15 images that are unannotated, right? So we'll be performing annotation over here. So we'll start annotation. So now you can see this is really interesting thing. You will be annotating some of the images for labeling it up. So we'll perform this thing, right? So for that sake of thing, what you can see here, this like it's automatically detecting and segmenting images, right? So let's see, this is an auto. So we'll perform and we'll write it up. It's an auto. So you can classify also, right? What you are doing. So this in that way, you can. So this in that way. So this is also an auto. So we'll be saving it as an auto. So save as an auto, and you can see over here, right, this as so I'll what I'm doing it like what I'm doing up here is like I'm not like classifying uh, you know this scooter with with bike, because we'll find very less scooter on road these days. So I'll also annotate this thing with with bike, right? So because we'll have a lot of different stuff over here, so we can't like go with everything to get a good result. So I'll annotate this thing with a person. So this thing I already annotated this person, right? So you can see you just need to click it up and this thing will automatically detect what it is. So you really need not to worry about the things. You just need to select this thing, right? And another way you can uh, do this thing, do this task. So, so in that way, right? So you can see over here, this is a car. So I'll set up this thing with a car. So I have like we have few people also over here. So I'll go with person, right? So like you can see there are a lot of autos. So like so you can just pick this thing and can, so in that way you can perform the annotation part, right? So you can also see over here this in that way this segmentation, what way the segmentation is doing, right? So you can see over here there's a person, bike, so there are a lot of stuff. So this is annotated wrong, so I'll delete this thing and I'll re-annotate this part. You just need to hold for a second and it will automatically detect what you are trying to annotate. So we will just go select auto, right? So for that sake of thing you need to go for the smart polygon. There is icon over here, smart polygon. If you want to do manually, then you can go for the polygon tool. So actually what I'm doing up here is segmentation, so I'm using polygon. If I would be going for the detection model, then I would have used this bounding box that we already used. So that way you can segment it. So this my first image is segmented. Now I'll go for the second image. So you can see over here this is car, so I'll segment it with car. I'll just classify it with car. So now you can see here it is an bike. So I'll go and you can see it's annotated wrong, so I'll delete it. So you need to go very slow because it's actually detect real time detection is there. So you need to be very steady while working with this thing. So I'll go this in that way. So yeah, so here I can see it's a person. So I'll go with the person, right? So there is another person coming from back. Let's see if I can, yeah, I can detect this thing. So let's say this is also a person. Okay. So I already have detectors. Like you can detect road also. I'm not using very much objects because I need to finish this video. Not I need to finish it very soon, so that's why I'm not using. But you can use it to perform your task. So you can see over here. So in that way you need to annotate this thing. I'll just making taking a pause over here, and I'll do this thing manually, so that like I'll not add all these things in my video. So I have already show you two images to how you can annotate two images like that. You can do it for the 15 images. So I'm just taking a pause over here. In the meantime, you can also take a pause and can annotate all those your 15, 20 minutes, whatever data set you have. And after that, like I'll perform the next task. So I'll just take a pause over here. Okay, so what we did is like we annotated all our images. As you can see, I have annotated all my images. So I haven't go to a lot more deeper annotation. Like I haven't annotated all the objects, but I have annotated, you know, important objects which I really want to segment it up. So I have done it for 15 images. I have shown you how to do it, so you can do it for your images, and you can select your number of data what you want. So I have taken like 15 images. So in that way you can annotate your images. So I have like annotated my images. I haven't taken like buses and rickshaws. There are a lot of things which are because in road there are a lot of objects. So if you really want to do this segmentation for each and every object, you can do it. So just for I really want to show you how the things work. So that for the ease of that thing, I have taken very limited objects. So you can take as number of object you want. Right? So I have these things. So I have already annotated my part. So what I'll do now is I'll go to my data set, right? So I'll go back. Now this is like annotated images I have. So I'll add those 15 images into my data. So as you can see over here, it is showing that 70% of the data would be good for training, 20% for validation, and 10% for training. Right. So I'll add this images. So images will be inserted. Now you can see over here data set 1 having 15 images. I'll go over there. So this is what my part is. So now what I'll do is right. So this is what I have. Now I'll go and I'll generate I'll go to generate. Now you can see there are like 15 images total. I have four classes, right? So like you see the classes also, and that way you can see like you can like back. I'll also let you know how number of classes I have taken. So the number of classes what I have taken is like bus. No, I have taken car, I have taken person, I have taken auto, and I have taken bike. So these four, classes I have taken. So it's showing over here. There are like four classes, 15 images we have. Now, what I'll do is I'll pre-process the data. So this is really an important thing. I would like you to know this thing. So what you need to do is, and you need to pre-process some. There's like pre-process augmentation you can do over here, so just to increase the number of data set if you have a limited data set. So in that way, I'll what I'll do, I'll select the grayscale. So just to you know change the pixels and all, it will generate some few more data. So I'll continue. Now this is an augmentation which is really important. So what I'll do is I flip it up, so you can see the left portion is going to right. So I'll apply, and I'll also apply rotation. So that way this like some generate some more images. So I'll go to continue. Now I have like 35 images in total, right? So I'll generate my data set. Now, it's very important part coming up here, in which format you need to download the data. So I'll show you in which format you have to download the data, just to not to get errors. So we'll wait for few time to get it generated. See, the image is already got annotated. So we can see over here an icon pops up that is of export dataset. So I'll click on export dataset. So what in which format I need to download, that is really important. What we're gonna do up here is we're gonna download this file as YOLO V8. YOLO V8. So in the format we need to download this file, and we'll download it as download zip to computer, right? So we'll go into continue. So it will automatically export the file into a zip folder, and you can see over here I have downloaded my folder. This folder consists of all the images that has been annotated, and also it's already splitted into 75% of training set, 13% of validating set, and 13% of testing. That thing you can also can change. I'll let you know how you can change it, but it is automatically get selected by this inbuilt algorithm of this tool. So you really need not to worry about how you have to change it. So it's you know in a good way it has been splitted. So no worries, right? So now I will go to my download section, right? So here you can see this thing. I'll cut it up and I'll put it into my folder of YouTube video. So I'll paste it over here. So you can see over here, here is a poster, it's in zip. So I'll extract this thing first. In this way that it will get extracted. So you can see over here, now you can see there is a folder of test, train, validation. In test you can see images, all the images that will be used for testing. So I'm using three images. On these three images I'll be predicting my model, and this is the label of this data set. So you can see, if I would open this test image, then you can see this is what the annotation did. So it is like giving it in a form of numerical numbers, so that machine can detect where we have done annotation. So this you really need not to worry about what it is. Just need to create folder in a good way, that's it. Okay, so we have test, we have train. In the train folder, you can see there are several images which will be used for training. So these are the images. I have done augmentation, so in that way it has converted images into grayscale. Also, flip it up and rotate it. So in that way we have a bigger data set, so that we can use it up, because I use very limited data set. So in that way I augmented my data set, right? So train, test, validation, and the very important folder we have is of data dot yml, right? So YAML, what it is, right? This is something we need to understand it, right? We can see over here we have train and we have this path. So here we will put the training path of from our end. I'll let you know at what step we need to put the path over here. And here you can see the number of classes I have. This is four. I have auto, I have bike, I have car, I have person. This is what, like, some different stuff which has been written by the Overflow itself. So really need not to worry about this thing. You can delete this thing also, doesn't matter, right? So in that way you can just control s and just save it, right? So, and this is some folder which is generated by RoboFlow, so you can delete it, or in what way, like if you don't delete it then it doesn't matter too, but I'll delete it up. So I have like this thing. So what I'll do is I'll go to that. Okay, so I have chosen, let just delete this thing. So, and we have the data set with me, right? So now what the next step I would do, right? So the next step would be to create some folders on drive, right? So we'll go to my drive, and I'll also create a folder, and that is the collab folder I would create, so that I can put a notebook in it. So I'll go to my, sorry for that, I'll go to my drive. Right. So what you need to do over here, just listen very carefully, because from here onward, we have to create our directory. We have to create our all environment where we will be putting our all stuff. So this is really important step over here. So first of all, create a folder with your model where your all models file would be saved and your all model would be stored. So I'll create a folder with image underscore segmentation, right? Because we are doing segmentation, so I'll create it. We can create it as traffic, or traffic objects underscore segmentation, or whatever, like whatever, and whatever you want to specify name. So I'll create object segmentation, just a name. You're gonna change it from your end, whatever you want to do. So this folder I have created, that is traffic underscore object underscore segmentation. That folder you need to create, you need to put some stuff, right? So the first folder I would create is image underscore data. So it has like all the images of, or we can say the object underscore data. It will consist of all the images of the data, all the images which we have annotated so far. So it will be put into that folder. So I'll create this folder, object underscore data. So this is being created by me. Under this folder, I'll upload some file. So I'll upload some folder, not file. I'll upload some folder. So what would be that folder? So I'll again go to my YouTube video. I'll again go to this thing. So I have like these three things. So I'll put all these three things into one by one. I'll upload. I'll first upload the validation folder into it, and then I'll upload the training folder into it. In that way, you need to upload all the folders into that specific folder. So I have train, validation, and then test, right? So in that way, I have like put all the three folders into this traffic underscore object underscore segmentation folder. So you need to understand like what I did. I'm again repeating. I created a folder named traffic underscore object underscore segmentation. It is the main folder you have for your model. Then under this folder, I have created an object underscore data. What does this object underscore data consist of? It consists of your images folders which you have annotated. very first folder is test, the second is train, and the third is validation, right? Valid. So apart from this, I'll also upload one more file into this folder, and that would be your data.yaml, right? So here I'll upload this thing, and also what you need to do is you need to here also you have to put that file data.yaml, right? So what I did, I create object underscore data, put all the four folders which was automatically created by that tool annotation tool. All those four folders you have to put into this folder, that is object underscore data. Apart from it, you have to put data.yml along with this folder also. Right now, in this the train underscore object underscore segmentation, you have to make a collab notebook, right? So I'll create a collab notebook also over here, right? So that way, so I guess like I have created and it's already opened. So I'll name this I'll name this thing as let's say object segmentation. So we are doing a traffic object segmentation. Traffic segmentation. I'll put traffic or whatever name you want to put. Right, it just doesn't make any difference. So I have like created this, right, traffic underscore segmentation. So you can see over here, right? You can see over here. So I just so you can see over here. I'll control S first. So it's been saved. So just close it up. I don't need right now. So okay, so you can see over here. Now it's refresh. So we can see a folder with the name object underscore data with annotation like which I did, and this classification. The YML file we have. So we put it over here too, and a new a notebook file, that is traffic underscore segmentation dot ipavanb, which I have created under this traffic underscore object underscore segmentation folder, right? So these are the three things which you need to put, and the last thing which I want you to put over here is the file which we have downloaded in the beginning, that is the model file. So the model file, I'll show you where it was downloaded so that you can recall it. So this is the YOLO V8 as segmentation which we downloaded in the beginning. So I'll put this thing also over here. So I'll go to this tech download folder, and I'll just put this thing over here. Right? So we have almost finished with all the things, right? All the folders, and we have to create it, and all other things which we need to put it on. So let me show you again what we did. So you can see over here we have this main folder, traffic underscore object underscore segmentation. Under this folder I have created object underscore data, data.yml, traffic underscore segment, that is the collab in which we have to work on. And this is the model, right? YOLO V8 segmentation model. Now under this object underscore data, I already told you these four folders are automatically created by the tool. I have only upload all these things into this object underscore data. So like you can also. All right. So this is all I did. Now what I'll do from here is I'll open up this folder traffic. Now I'll be working on my collab. So there will be a little a little code you have to put it in so that your pre-trained model would get to know what changes I have made, right? Now first of all, what you need to do is you need to change your runtime first. So I'll change my runtime to GPU. Right? So it is really important to put your hardware accelerator to GPU and just connect, right? So I'll connect it now. First of all, you can follow me, or you can later on I already told you I'll put all the stuff to my GitHub repo, and I'll also share the link of that GitHub repo so you can download from over there too, or else you can follow this video. I have like created all the things live, so you can just follow me and can get to the results. So it's upon you, whatever way you want to follow, right? So I'll first import Wes, right? Then I'll import home equal to host dot get cwd. And I close this thing, right? And then I'll print home, right? So that way you can do this thing. So we can see the content come up. So now we need to change the second thing. We need to the very important thing from here is to install the YOLO V8, right? So what I'll do first is I'll delete this thing. So from here onward, you what you can do is like you can change the speed to 1.5x if you don't want to get into this coding. You will get the notebook file of IPYNB from my end, so you can just change over there also. So I'm just doing it because there are few people who want to code rather than like use that predefined notebook. So I'm installing YOLO V8, right? So right. So I'll just install this YOLO V8. Now I'll code. So for that sake of thing, I'll go pip install. So I'll be installing this YOLO V8. So I'll be installing this YOLO V8, but before that I need to install this Ultralytics. I'll use pip install Ultralytics. The version I'll be using was 8.0, and then I'll import the display. So from my Python, I'll be importing display, and then I'll clear the output. So display dot output, right? Then and like I already have this, so I'll import this Ultralytics, and I'll check this thing on dot, right. Okay, so I did what I did. X. Okay. Okay. I hope this will run. Okay. So I guess. Okay. So I need to just use just a little spelling mistake I did, right? Then what I'll do is I'll be importing the yellow. So from where I'll be importing the yellow from Ultralytics, which I did is from Ultralytics import yellow, and then from my Python.display I'll use import import display, the same display. Okay. All right. Okay, from display, and I'll be using image. Okay, I need to. So you just need to take care of spellings because it's case sensitive. So it's really important to always use correct things. So now I'll be mounting the drive. So there are two way to mount a drive. The first one is to get into this icon that is of mounting drive. You can just click it up and your drive will be mounted. And the second way is to write a code. So I'll show you how to mount a drive by writing a code. Uh, Mounting drive. I'll just you get to know that here we have mounted the drive. Now I'll write a code about mounting a drive. That is very simple. That is from Google.Colab import drive, and you need to just mount your drive. So I'll be mounting my drive. It will ask me for the permission. So I'll so I allow that. Now your mounting is done. Your drive is already mounted. Right. So the next step would be of like cloning that Ultralytic repo, right? So to clone a repo, I already told you we need to clone the repo. So I'll tell you what repo we are cloning. So here it is a link of the GitHub repo which we will be cloning. So I'll just put that link into my uh, under my video so that you can just access it. So what you need to do is you need to just click it up here and your link will be copied. Now what you need to do is you need to just write it up here, git clone space, and you have to just paste your thing, right? So next step is like clone. So my cloning is done, right? You can check. Yeah, here it is. It's already done. So your all cloning is done. Now the next step is of setting up a root path. So I'll set my root path as root underscore path equal to, let's say my root path is my root path is like I have to assign my root path as my model. So this is what my model is. It is under the my drive section. So in that way you need to specify your path of your model. So the main folder path, like I already have copied it. So now I will be pasting that thing, right? So now my root path will be set. So my root path is this now. You want to check either you're doing right or not. So what you need to do is you need to check your present working directory. So I'll check my present working directory. I'll check my present working directory, and this working directory is content, right? So I'm inside the content right now. Now, now what I need to do is I need to go to the working directory. So that is I'll assign it. So let's say where I have to go. I'll select this percent, then I'll select okay cd, and then I'll select my directory to be. I need to go to this. So I need to go under this thing. This do that. And now let's see. So I'm under this drive, under this my drive, and I'm finally into this traffic underscore object underscore detection. So if I need to, let's say I need to check if it is I'm in the right track or not, I need to check the present working directory. So I'll check the present working directory and it will show me I am under the traffic underscore object underscore segmentation. If you want to check the number of lists you have inside this thing, so you can check it by ls, right? So we have like four things inside this traffic underscore object underscore segmentation, that is data.yml, objects underscore data, traffic underscore this is like this is my yml file, this is my folder in which my training data set, testing and validation data set is there, and this is my notebook, this one notebook, and this is my model, right? Now the next step is I already done this step. Now we'll be moving forward for our custom training. But before proceeding into the custom training, we need to do some changes in data.yml, right? So to do some changes, under this data.yml. So you can see here. In this data.yml, we have training, validation, and test. So we need to assign a path to the training, to the validation, and to the test. So we need to go to under object underscore data, and we'll go for the training first. So I'll go under the training section, and I'll select this images, and I'll click it up and then copy the path, and I'll just put the training path over here. So you can see the training path is all set. Now for the same, I need to do it for validation. I'll go for valid, then I'll go for the images, and I'll select the image path, and I'll just put the image path over here, right? So for this is for validation. Now for the test, the same stuff I'm gonna do. I'll go in the test, I'll go in the images, and I'll copy the path, and I'll put it over here, right? So you can see it's quite easy, just to give the path. So now we have already given the path. So I'll select Control S. Now I'll be just move out from this thing. The same way, what you can do is, if you want, then you can also, like you can see over here, this is data.yml. This in this section I haven't given any path. So in either way, you can also give the path to this training, validation, test, or there is no need, because this is what, this is under this training, test, and validation. But what data.yml we are using is of outside of our this folder. So this is the one which we will be using for training our model. So there is no necessary importance of this data.yml. I have just put it under this section because usually people use it and to move it from one folder to another folder by coding. I haven't used code. I just move it. I just copy it and just paste it outside of this folder. So it's okay to have this folder with you. And if you are giving the path, it's fine. Like let me just give this path to just to make out the confusion out from your mind. Okay, so what I'll do is, right, you can see over here, this is one, and this is the second one. Yeah, so I'll do one thing. I'll just paste this thing so that there wouldn't be any confusion. Control C. So it doesn't make any difference if you'll not give it. I'm just giving it so that you're not, having any confusion that, why we have put this thing under this section. So just give it, no worries. It doesn't make any difference at all. So for the test, so do the same step for test. You can take it from there also. I'm taking it from here. Right. So this way, so I have given like both data.yml the path, right? Fine. So now, since we have given the path to the data.yml section, now we'll move forward for our custom training, right? So I'll write it over here. I'll take a text and I'll write custom training, right? So now this is very important thing coming up here, uh, because now we are dealing with segmentation. So prior to that, you can use a different model. Since like I have used YOLO V8 segmentation. If you want to do detection, you can use YOLO V8 detection model, and after this you can make change for detection. Prior to that, all the things would be same, just this thing would be different, right? But we are going for segmentation, so we'll be doing all the stuff for segmentation. Now I'll be doing the custom training for my segmentation. So what I'll do is, like, I'll write YOLO task, right, and I'll equal to, so the task is segment, so I'll write it over segment, and after that I'll write the mode would be train. So because I'm performing the training, so I'll be using train over here. Now I'll be using the model would be equal to YOLO V8 segment PT. So this thing, this same thing, uh, you know will be written over here. So I'll be writing the same model name, so YOLO V8 as segpt seg.pt, right? This pt is actually a pytorch file. So so we have written this thing. Now we need to move forward for our data. So the data is like data.yml, under which the classes are. So I'll be writing the data.yml, and then after that I need to give the epoch. So the number of epoches I'm giving over here is, mm, I'm giving the number of epochs equal to, let's say I'm giving 200. 200 is more than sufficient. And then I need to give the image size. So I'll give the image size as image size as 640. Okay. And let's say okay. So I'll be now, after that I'll be saving this as save equal to true. Right. So my custom training, so I'll execute this file and wait this file to run. Since I have select my runtime as a GPU, okay, image size is not a valid YOLO argument. Okay, let me see what I have done wrong. Okay, I have done wrong. What I have done wrong? Data equal to YML. That's fine. Image size IMA is 0. So let's see what we have done wrong. Let's just rerun it. Maybe there will be some problem back. Okay, now it's running fine. So you need to just give your let me again tell you what I have done, because there is a lot of time, because it would take a lot of time. So I have given the task of YOLO, that is segment, right? This is the first thing I have given. Second thing which I have given is the mode. What do you want this thing to do by what? So I want the mode to be trained. I want this training to be executed, and then I have given a model. The model will give you what you are trying to do from the PyTorch library, because YOLO V8 run in PyTorch. So this mode is like, segmentation. Second is like data, which contain the classes. So I have executed this thing. I already made changes. I have shown you just few minutes back, and I have selected the number of epochs to be 200. Image size is 640. Right. So you can see now this is what we were waiting for. Now the epochs are running right now. So we have come across to the fifth epochs. So as you can see, as the epochs are being proceeding, the box loss, segmentation loss, and class loss is getting reduced. So what does this box loss, segmentation loss, and classes loss means, right? So the box loss is actually the detection if that particular model is, because in this segmentation model will, because first of all, this the image to be detected, then only the segmentation part can be done. So the box logs is determining you if that particular object is being detected fine or not, right? So this losses, the number of losses, this epochs is getting reduced, and this box logs is just showing you all the stuff of the detection losses. This is the segmentation losses. Either the object is, segmented truly or not, or how much loss it is in segmentation. So this segmentation loss is just reflecting all these things. Classes loss is like I have given four classes, right? So how truly the classes is being determined. This is class loss means like the number, like, you should reduce the class loss as much as you can to get more accurate and fine result. So let's see what would be the optimized epochs it would run for the image size to be 640, and for the image size and epochs to be 200. I'll take a pause right now, and I'll just take a pause and wait this epox to run, because it will take a lot of time, because I have given epox 200. You can give a lesser epox, but just to show you a little more accurate results, I have taken epox to be 200. This model is running. I'm taking a pause for a while. I'll just come up when this epoch would be completed, and I'll show you the next step, how we can do the validation and the prediction after that, right? This model is almost 70% completed, because the training is all done. Now I have to check for my valid data, how the training is performing on the valid data. Then I'll be running my final predictions in the predicted data, that is test data, right? So I'll take a break. I'll take a pause for a few minutes in and in the meantime, what you can do is, like, you can just go through all the things what I have done. No worries, I'll upload all this whole notebook into my under my video section, so you can go through that. My GitHub repo will also be there under that section. This whole model would also be there. You can just change few things. At the end of this video, I'll also tell you what are the changes you have to make for your custom data and to get your desired result. So no worries, it will imply all of the images and all of the models which you are being want to work on. So guys, you can see the epochs are now stopped. The training is stopped, and it has run for 97 epoch out of 200. So there would be some question arises in your mind that how it has stopped on 97 while I have given the number of epochs to be 200, right? So since it, like, let's say the last epoch was 97, so at that epoch my box loss was zero point 0.5, my segmentation loss was approx to 1, and the classes were loss was 0.51. Now see, since I have given a very less data, if you will given more data, then the segmentation loss would be less, and it should be the considerable amount of loss to be fine is equal to zero point 0.1. If you would have losses around zero point 0.1, that is approximately considerable and good. So try to run for the losses to be zero point 0.1, and it would only occur if you will optimize your model by adding number of images, by doing lot more augmentation. So just to show you how the model work, I have taken a very less number of data. That is why my segmentation loss is coming to be 1.08 and this thing. Now the question the question was in your mind, maybe some of people might be in your mind, right? Why it is 97 out of 200? So since it checked for a few back epochs, if there wouldn't be no progress in the losses, if there wouldn't be no considerable, you know less losses in the upcoming epochs, then it start in the optimization epoch. So this is considered to be the epoch in which there wouldn't be any, they are not having less losses. So this is the model itself result out to be the best epoch. So let's, you can also just read it out here. Stopping training early has no improvement observed in last 50 epochs. So from the best, this 50 epochs, there is no improvement. So best result is, it's also tell you where the best result was. The best result was at as epoch 47. So they will consider that weight of that epoch only. So now we have this training data set, and this training data set actually saved, in the run folder. You can see over here there is a run folder. Here we have segmentation. So under the segmentation, this is the training folder we have. In the training folder, we would have the weight file. So this weight file is the file which would be having our all the necessary weight of this training. Now let me tell you one thing more. If you would rerun this thing, there would be a different training folder generated, because if you would change some data into the training custom training, it will reassign a different weight, and it will have a different training folder. So let's say if I would change this box to 150 or image size to be 700, then or might be change some hypermetric tuning, hyperparametric, or whatever I'm doing in the configuration and all. So it will change the train folder to train one. That train folder would be there. There would be different train one folder, under which there would be same folders would be there, but the weight would be different. Now the weight would have a different batch.pd and last.pd, right? So this is the something which would be very much important when you will be deploying your model. So if you're just training this thing one time, then you have to take this weight. If you're training it for multiple, for just to check where your model performed very best and you're getting less losses, then you have to train it again, and for number of training, you will get number of train file and number of weight file, right? So this is the train, and then next if you'll train, you will get train 1, then train 2. So you have to use that only weight file in your validation code, right? So I'll write the validation code. I'm writing this validation code for my train folder, my for my custom training one, right? So I'll write it up as since go for the validation, right? So I'll write same as I have written a few minutes back. YOLO equal to Euro task. First of all, I'll assign Euro task. Euro task is same as it is doing segmentation. So I'll be writing up segment, right? And then after that, I'll assign the mode, and mode is equal to, now I'm going for valid. So I'll write it up here valid. Since you can see in training, I have written train, right? So in that way, you can also distinguish between them. What I'm doing. Now I have written valid. Now I'll go and assign my model. So the model would be now since when I use my training, then I have assigned the model to be this thing. You can see YOLO V8 as segment.pt. All right. Now I'm doing validation, and validation is done on the training data set. So the valid model, the model which will be used for validation would be training weight, that as.pt. So I'll just copy this path, and I'll just write it here. Right now, after that thing, I'll write my data, what data I'm using, and data I'm using my classes, that data.yml file, YAML. Right now, since I have written this thing, I can run my validation, so I can check my thing. It wouldn't take much time because training took a lot of time because it have to run for the epoch. So what went wrong? Mode equal to valid. Okay, let me check what I did wrong. Invalid mode equal to, okay, segment mode equal to valid. Okay. I have done. I guess I have done something wrong over here. Okay, I have to write well because I'm using validation. So there was an error. Now it wouldn't take any error. Okay, so I have written valid. I have to write over there well, right? So these are some of the few and very small thing which we have to take care of before proceeding into this thing, right? So in that way your validation would run. Now the next thing which I have to do is my predictions. So that prediction is being done on the test images. So I'll be writing up here first. I'll be writing here predictions so that everyone would know prediction. And when I'll upload my file while this notebook into my GitHub repo, then you will get to know what I'm doing also, what I have done, so that you can change accordingly. So now I have to go for the prediction. So I'll write it up here. Your task, the same task equal to segment. I hope you may have learned this thing because it's so easy. Thousand times I have done like for. Okay, so now I need to assign my prediction. So that I have done. Now I have to do predict, right? PRED, because I'm doing it for prediction to predict. And segment done, predict done. Now I have to assign the model, right? And the model would be same because what we are doing, we are just asking the result from the weight file, best.pt file. So I'll just do that thing. Okay, now the next thing is, this is a little different. So prediction I have done. I have write it for that model. Now what I need to do is I need to write the config, right? I need to write for config. So I'll select my config as 0.25 by default. So you can change it, right? Now I'll write my source where we want my prediction to be done. So the source file, as you know, the source file will contain my test images. So this test images will be in the. So this is my test images. So copy path, and I'll just give my source images. I have given my source images. Now save equal to true. Now the next thing is save equal to true, and we'll wait. Let's say just execute this thing. Now it's getting executed. So as you can see over here, results save to run slash segment slash predict. So now we need to see the results. So the result would be saved on my folders. Now I'll check my folders, right? So I'll go to segment, I'll go to the predictions. Now I have to see if this model, this algorithm has done his work fine or not. So let's just check for the 13th one. Oh my God, that's really great. So let's see. The car is predicted very well. The persons are predicted very well. Even the Activa, this thing is predicted wrong. Yeah, this thing is predicted wrong since it is predicted as person, but it was a bike. So the car is predicted well. Overall, pretty good results I got. Let's check for this thing. Okay, now you can see okay. So the persons are predicting pretty well. Bike predicted pretty well. Bike predicted pretty well. Car. So you can see, like, but let me assure you one thing: if you would, put more data and do a pretty good annotation, you will get a very good results. I have done so fast to just to show you in what way I'm doing it. Still, it predicted pretty well. That you can see the bike predicted very well. Person, autos. It has predicted auto, but it was car though, and you can see the person, the bike, prior one. So it's done pretty well. So now if you want this thing is done, right? So if you want your model visualization, how are you going to do that? For that thing also, this particular set has a beautiful inbuilt thing. So what you can do is you can go to your run and you can check for your predictions, and since you have seen this prediction is there, so you can go to, okay, so you can check your validation. You can see this is the confusion matrix it has made. So you can check this confusion matrix and can, you know uh, go for the visualization. You can go this thing. So all being thing is present would be there. So you really need not to worry about what you have done and what you haven't. So all the things would be there. Now the next thing is like how this you can segmentation part. I hope you may have, learn a lot, and you can segment now your image segmentation pretty well. And this is what from my side. And stay with me, subscribe my channel so that you can learn a lot of upcoming things from very scratch. I have made this model from very scratch, so everyone can learn this thing. Everyone can know how to segment the images. Later on I'll be putting my video on TensorFlow, mask, RCN, segmentation, and some of the detection models I'll be coming up with, and some of new more AI computer vision technique to learn. So stick with me.